Hello students, welcome to the interesting chemistry. In continuance of the redox reactions, it's my fourth video. In my first video, I discussed you with the old concept of the redox reaction. I mean to say oxidation and reduction. And in second video, I gave the modern concept about the redox reaction, that is electron transfer concept. And in my third video, I told about the oxidation number. So, how today I will tell you that how will you ascertain or calculate the oxidation number. So for this exercise I have taken some examples and make some questions I will discuss one by one. And before that I will also tell you the assumption of electron transfer in oxidation number. What is this assumption of electron transfer? Electron transfer is found in the ionic compound. But here in covalent compounds, we assume that there is electron transfer. With the help of this assumption, we can calculate the oxidation number of the covalent compounds. So, without getting any late, I am starting the video with the first question, that is the justify the oxidation number of O2 is 0, Cl2 is Cl2O, the oxidation number of oxygen in O2 is 0, in Cl2O it is -2, in OF2 it is +2, and it is S2O2. In S2O2 it is -1. This I have told in the set rule of the oxidation number, that O2 is 0 and OF2 is -2, and in this S2O2 it is -1, and Cl2O it is -2. So I also told you that the oxidation number of oxygen is always -2, except the O2 is 0, OF2 is +2, here is -2, and here is -1. So you should have, how will you justify this? So for this justification, I am giving some examples to make you more understand. That first take, suppose what is the code? Here the hydrogen in S2, hydrogen and hydrogen have a covalent bond. So this electron pair called the bonded electron pair. So see the location of the bonded electron pair. In this hydrogen, the bonded electron pair is located between the two hydrogen atom, and the distance of this bonded electron pair is equal from each hydrogen. So this is the electron density of each hydrogen is equal. And what I am saying, listen it carefully. The electron density, the distribution of the electron density on both the hydrogen atom is equal. So there is no question arises of forming the formal charge. So hence in the H2, the oxidation number of hydrogen in H2 is equal to 0. In the same manner, when Cl, there is a bonded electron pair, and this bonded electron pair is also situated between the two chlorine atom. So the distance of this bonded electron pair from this chlorine or from this chlorine is equal. So again I am stressing the electron density. The electron density on the each chlorine atom is equal. So the here in Cl2 the oxidation number of chlorine will be 0. But now I am coming to the HCl. HCl here H and Cl here. This is the bonded electron pair. I have written this bonded pair of electron towards chlorine. Now compare the electronegativity of the hydrogen and chlorine. Compare so the electronegativity of the chlorine is more than hydrogen. So this bonded pair of electron shifts towards the chlorine. So the distribution of electron density will be more on the chlorine. So the electron density on the chlorine atom is higher than the hydrogen. So how will you show the electron density is more on the chlorine atom? That will be shown by a formal charge. By a formal charge that is delta negative. Delta negative and this hydrogen on delta positive. This is the main principle of the assumption of electron transfer among the covalent compounds and the covalent bond. So here in my previous video I told you about the bonded pair of electrons shifts towards the more electronegative element. Hence the counting of the bonded electron pair will be with the more electronegative element. So this bonded electron pair will be counted with the chlorine atom as it is more electronegative. But here, see, here it is only a shifting. Now come to the assumption of the electron transfer. It is a slight shift towards the chlorine, towards the more electronegative compound. So a partial electron negative charge is occurred on the chlorine. So now we assume that there is a electron transfer with the assumption of electron transfer. Here we assumed, without assuming, we can't count the oxidation number. Here we assume. So here when we assume that there is a electron transfer like Na positive and Cl negative, it is Na plus 1 and it is chloride minus 1. In the same way it is also HCl, H positive and Cl negative. It is assumed, this structure is assumed. So here it is plus 1 and here it is minus 1. In this way, as in HCl, the oxidation number of hydrogen is plus 1 and its chlorine it is minus 1. So I think that you have understood the assumption of electron transfer. So now I am telling you about my question that the oxidation number of O2 is 0. This is the electronic structure of O2. Sure. Oh, I'm very sorry. This is the electronic structure of O2. So here, both the oxygen has 6 electrons in the outermost orbit. 2 electrons of each oxygen are bonded with each other. So here this oxygen, both the O electron both the O atom have similar electronegativity, then no question arises of shifting the bonded pair of electrons. So both the electron pair will be located on the center of the oxygen atom, so the distribution of the electron density will be equal. So no question arises of the partial charge. So it is O2, then O2 is equal to the oxidation number is 0. Here we can't assume the transfer of electrons because the electron density of both the oxygen atom is equal. So the bonded electron pair is located or situated in the middle of the oxygen atoms. So O2 is equal to, here O2 is oxidation number of O2 is 0. Again I am telling you Cl2O, and here I have written OCl2. What will you write, Cl2O or OCl2? You will have to write Cl2O, and here you will write the OF2. Here O comes first, here Cl comes first. So it is a tradition. It's a tradition. The electropositive element or the electropositive part of a compound, of a formula of a compound is written on the left hand side, electropositive part, and the electronegative part on the left side. So you can't write OCl2 because in this Cl2O, the electronegativity, the electronegativity of oxygen is greater than Cl. Is greater than Cl. This is the electronegativity of Cl, and F is more. So the ratio of the fluorine is more electronegative than O is more electronegative than Cl. So here the shifting of the bonding. Now think about this shifting of the bonded pair. Here is a bonded electron pair. In which side the bonded pair of electron will shift? So here in this case the electronegativity of O is more than the bonded electron pair will be shift towards oxygen. So the bonded electron pair shifts towards the oxygen, hence the electron density of the oxygen will be more than chlorine. So here in this case they are negative charge and this is positive charge. This is positive, a partial. So it shows us a shifting. With the shifting of this, we can assume that it is in case of electron transfer. We assume that it is a transfer. So here it is positive and negative. So in this case, in OCl2, in Cl2O, the oxidation number of oxygen is -2. You can calculate here 2 into -1, 2 into -1. The oxidation number of chlorine is -1. Here are 2 chlorines. So plus, this is X, this is O. The oxidation number of O is X and equal to 0. Equal to 0. In my previous video, I told the algebraic sum of the oxidation number of in a compound are 0. So here, if we can put here 0, so again it is X is equal to -2. Sorry, here it is, in this case it is +1. Here it is +1. Always chlorine is found as a negative, but in the case of the OCl2, In OCl2, it is more electronegative than Cl. So here Cl acts as a positive. So it is a loser of electron because oxygen attracts the electron more than Cl. So the electron pair shifts towards the oxygen. So as this Cl acts as a positive. Here the Cl, the oxidation number of Cl is +1. So again X is equal to -2. X is equal to -2. X is equal to -2. So in this case, as I told you that the oxidation number of oxygen is always -2, except in O2. Except in OF2 and H2O2. In OF, now I will discuss here the oxygen. Now I think that you have understood what I am going to tell you about this OF2. F is more electronegative. The electronegativity is more. F is more than oxygen atom. So the bonded pair of electron shifts towards the fluorine. So the delta partial negative charge will occur on fluorine atom, and on oxygen there will be a positive part. So how will you calculate the suppose OF2? Suppose this is the oxidation number of O, and there are two fluorine. Fluorine is in minus, so it is 0. So again X is equal to +2. So in OF2, the oxidation number of the O is +2. I told you O2 is 0, -2 and +1. Here H2O2. The structure of H2O2 is in this case, here, like this. There is one. This oxygen is bonded with a single bond. So here one bonded electron pair, both the oxygen atom have the similar electronegativity. So this electron, the bonded pair of electron will be located in the center of both the oxygen atom. So here again only one electron. This electron. This bonded pair of electron will shift towards oxygen. This bonded pair of electron will shift towards oxygen. So here delta negative and delta positive. Here delta positive and here delta negative. In this case, calculate the oxidation number of O2. Here are H2. First you will take, there are two hydrogen. Hydrogen is positive. Here O is negative. So hydrogen is +1. I told you in my previous, except the hydrides of the first or second group, NaCl2. The oxidation number of hydrogen is always be +1. So here 2 into +1 plus 2x for O2, 2 atom of oxygen 2, and x is here. Again here right. So here 2x is equal to -2 and x is equal to -1. X is equal to -1. Here I have justified the first question, that the assumption of electron. I think that you have understood about all what I want to tell you about the oxidation number, that this is a rule in the set of rules to calculate the oxidation number. So I explained the question 1. Now you can how will you calculate in the second question? There are 4 compounds, K2MnO4. Calculate the oxidation number of the underlined element. Here K2MnO4. What is the oxidation number of Mn? Here you can write. So K is positive. The way of calculating 2, you will write 2 for n into +1. plus 1 for K, the oxidation number of potassium is plus 1, Mn plus X. Please watch it, note it, how am I writing, making the equation. There is 4 oxygen, there are 4. So 4 oxygen means 4, and the oxidation number of oxygen is minus 2. So it is minus 2. This will be written in bracket is equal to 0. Is equal to 0. So I think x will plus 6. X plus 6. If you write x is equal to 6, this is the oxidation number, it is wrong. You will get no marks in the if you write 6, because I told you the oxidation number is always represented with a plus or a minus sign. Always put a plus or a minus sign before the oxidation number. So the oxidation number here, the Mn is 6. You can calculate minus 8 plus 2 minus 6 and 6. So plus 6 here. Na2S2O3 2 for 2Na into plus 1 plus 2x minus 2 3 into minus 2 is equal to 0. This is equation. This is Na2 plus 1 is the oxidation number of sodium. S2, you have to calculate the number of the oxidation number as to 2x, and there are 3 oxygens are there, 3, and the oxidation number of oxygen is minus 2. So this is the equation. You can tell 2x is equal to minus 6 plus 2 minus 4, and this is 4. So x is equal to 2. This you can write. I may be wrong here in calculating the value of x, but the equation which I have written, that is correct. Again, calculate the oxidation number of Cl in SClO3. In SClO3, here H plus 1 plus X plus 3 into minus 2 is equal to 0. 3 to 6 minus 6, 5. So X is equal to plus 5. It is here in this case chlorine. The oxidation number of chlorine is plus 5 in the case. And here NaHPO2, sodium hydrogen phosphide. So here again the oxidation number of phosphorus. What is the oxidation number of phosphorus? So here again plus 1 for sodium, plus 1 for sodium, plus 1 for hydrogen, plus X for phosphorus, and O2 into minus 2 is equal to 0. Is equal to 0. So here 1 plus X plus minus 4 is equal to 0. So X is equal to plus 2. X is equal to plus 2. This is the value of the phosphorus. Here the phosphorus is in the oxidation number of phosphorus is PO2. So 2 minus 2 in the is PO2. So again, in question, now come to the question, third question. K2Cr2O7, K2CrO4 and CrO. There are 5 compounds. There are 5 compounds, and you have to calculate the oxidation number of chromium. You have to calculate the oxidation number of chromium. I have selected 5 compounds. K2Cr2O7. K2 here KS2. You will write here 2 into plus 1 for K. 2 into plus 1 for K. Kr2, Cr2. Here 2 Cr. So 2 into X. Suppose the oxidation number of chromium is 2. X, so 2X and 7 oxygen plus there are 7 oxygen 4 and the oxidation number of oxygen is -2 and equal to 0. This is a simple algebraic equation. You can calculate the value of X. What will be the X value of 7, 14, 12? So 2X is equal to, I think that is, 12 and X is equal to +6. May I correct? So here again Na2S2O3. Na2S2O3 calculate. Sure. Here Cr2 7, 2, 4, 14, 6. Cr2 is in 6 plus 6. K2CrO4. Here 2 into plus 1 plus CrX plus O4. 4 into -2 is equal to 0, and you can write 2 plus X -8 is equal to 0. So X is again +6. X is here is also X is CrO2 Cl2. Here you can write in this way X 2 into -2 plus 2 into -1 is equal to 0. This is the equation. Cr is equal to X. O2 2 into 2 -2. So chlorine 2 into -1. So here -4 and -2. So all the 6. -4 -2 -6. X is equal to +6. Again here the oxidation number of Cr, both all the here +6 and Cr at 3. It is very easy that Crx is equal to X is equal to +3. The chromium here, because fluorine X -3 is equal to 0. So X is Cr2O3. Cr2O3 here also the Cr here 2Cr. 2Cr, it means 2Cx, 2x, 3O, 3 into -2 is equal to 0. So X is equal to +3. X is equal to +3. You can get. So I think that you can calculate this all the oxidation number in this section. Now I will this video is going very long, so both the 4 and 5th and 6th questions I will tag in my coming video. So please here, that's all for today. So I think that you will learn more about. So I have given you some questions. In my next video I will solve all these 4, 5 and 6 questions. Then so you can then pause this video and calculate this number of oxidation of Cl, Ni and PO. This is your assignment. You should calculate and tally with me in my coming video. I hope that you have learned something about the calculation of the oxidation number. This calculation of the oxidation number will help you to equate the ionic equation of this. That's all for today. Thank you very much.